Okay, this part of the lesson is going to take in slides 7 to 13. And our main focus is on user input. And compared to the formatting codes, it will seem like a piece of cake. But in the end, we come back to the formatting codes using it with the input function, and hopefully things start to fall into place with the formatting. And you see how it's used outside of just a hypothetical situation. All right, so here we have basically it was discussed in chapter 1, having Python ask the user for input and saving that data under a variable name. Then we use a variable name elsewhere. We've kind of been doing that already. And so you can put some of these code snippets into your practice file, and I'll let you know at the point when we are moving into a lab file. So name1 equals, input. We ask the user for their name, okay? And we're doing that little bit more compact version than they show in the book in chapter 1. Then we turn around and print hello plus name1 plus exclamation, okay? I like to call this the input prompt. That's what's helping the user to know exactly what do you want me to put in here. And the better you write that, the better the outcome will be. Okay? When we look at that kind of program that we did before with the number of CDs and LPs, adding that together to number of albums, we right away see the limit of that because, people have a different number of CDs and LPs than what's shown. So we want to make it more dynamic, user-driven. Some members of the class already went ahead and implemented this difference in their last assignment. And so it's really not too much of a jump from what we did. In fact, if we wanted to go crazy, we don't need to assume that the user has CDs and LPs. We could ask them to choose what kind of media they have first, and then proceed to ask them how many of each. So you can really make your programs responsive to the user, but that's a little bit more involved, and we'll go into that later. So, getting numeric data in the input prompt has some wrinkles to it. So let's talk about that. The input function only accepts string data. So even if we ask for a number and they enter a number, we would need to convert it to a numeric type if we want to use it in a math problem. So it's no problem, really. We just have to tell it what we want to do. So number of CDs, you'd think we'd say input how many CDs do you own, but we actually have to put that inside an int conversion so it ends up that number of CDs is actually an integer, okay? Same if we were to want a decimal. We would do a float conversion rather than int. Enter your age, use a decimal for a partial year. In that case, they could say, like my grandson's famous for saying he's 5 1/4, so 5.25. In the future, we will be validating what the user puts in before we do the int and the float conversion, because right now, if the user puts a word in here, and then we try to run an int conversion against it, that will immediately go to an error and mess things up. So for right now, this lesson, we're going to act like people cooperate and they enter what we have in mind. Next time, we will start validating input. Okay. Here is a rewrite of that program using the input prompt rather than hard coding numbers. And so if you would like to take a copy of that and run it, you'll see that it asks you your information then. And Basically, it's worthwhile to study this because input collects a string. We need it to be an int in order to do math. But then we need it to be a string again in order to print it. So, you know, I guess there's a little bit of a irritation there where you say like, I'd just like to stick with one data type. But we're not able to do that. Instead, we just had to get used to going back and forth between numeric and string depending on what we need to do at that step of our program. So even within a program, a piece of data may have several types as it flows through depending on the operation taking place on that line. And so same with nesting. We have to make sure that we have the correct order. Like we had to have the input inside the int. You can't go in the other, order with that. Okay? Moving forward, this is just to point out that float is working just like int in the previous slide. The nesting works the same, the flip-flopping of types, and so forth. Also, I hope you notice sometimes I use a comma to combine strings and variables. Sometimes I will use a plus sign. And again, that goes back to if I want a space here, the comma automatically adds the space. Whereas if I use a plus sign, I have to manually add the space. So just try to get used to that and decide what is the most efficient for you. They both work fine. They're both perfectly acceptable. One of them just saves a little bit of time and keystrokes. So, flip-flopping data types. This piece of code will become part of the lab. It will be adapted for the lab. So, all of the code samples above, they should be in your practice file. Starting with this one, I did open a new file, and that file is called Coffee Sales. I put a 1 because I've done this program before, so I needed to, have a different name, but yours would be coffee_sales.py. You're going to need your doc string, and then probably want to use better comments than what I show here, because I'm just trying to, definitely show you which slide I get this information from. So if I take slide 12 and 13 together, okay, they won't all be included in the lab file, but this is for demonstration purposes. If I take slide 12 and 13 code together, first let's just say I run slide 12, and it's going to ask me how many cups of coffee sold. And so I'm just running slide 12 right now. It says run the code saying you sold 40 cups of coffee and the price is going to be $2.50. So if I say 40 here and price $2.50, then it says total sales equals 100. And it looks pretty good. That's using our old formatting method, the format function. Okay? And so the purpose of slide 13 is to move us to the new formatting method. For instance, the F-string formatting would print the same thing, but you can see, look how much shorter it is. And so we prefer it whenever we can to use, a shorter method. So this line of 12 would be preferable to 8 as far as printing the same information. Then the plot thickens. Let's make sure we finished off slide 12. It also says to try running the code with 500 cups of coffee, same price. Okay, what the heck? So if I run that, still works. And this is for the purpose of showing that the formatting codes that we're using, they are set up to accept a bigger number. And that's important if you want your coffee shop to succeed. So flexibility in that respect is good. If we were to enter, if it says how many cups of coffee you sold and you enter 1.5, that will go to an error. So this is for the purpose of demonstrating even between int and float. This is asking for an int. If I put 1.5 here, it's going to go to an error. Okay, so we don't need to show that in order for you to try it on your own. But the point being is that each of these lines of data has a type assigned automatically. So the first one is forced to be an int, the second one is forced to be a float. But this one here, coffee sales, what's automatically assigned? It asks you. So I'll let you think about that for a second. But whenever you have an int times a float, the float is going to take over and it's going to prevail. So coffee sales is a float. Keeping that in mind. So our challenge, though, is to print a table, and that's where, this code is just an alternative for printing the total sales equals whatever. This actually prints our table. So I did put that in my file, and that's why when I ran my code, I got this piece down here. Gross sales today for 500 cups of coffee. Price per cup, $250. Total sales, $12.50. And that is bringing together the earlier slides that we talked about, the dot format method, with our input lesson. So basically, hopefully it'll start to seem useful. We want a receipt format. And so in this case, the dot format method is being run against three pieces: price per cup, a $, and then the price. On the next row, the dot format method is being run against total sales, the $, and coffee sales, the variable. So this line here is fairly simple. It's just saying gross sales today for, and then substituting the number of cups of coffee. But this is one of those, irritating charts or tables. And so even with a 2-column receipt, you end up with 1, 2, 3 formatting codes. 1, 2, 3. So the left-hand column here is being forced to be 20 wide, left justified. The $, is we're leaving 3 spaces and right aligned. And then the price and the total sales, 8.2F. I went ahead and put the thousand separator in both of them. It doesn't hurt to have it there anytime you have a number. And so these codes should look familiar from last time. The new piece is the alignment and that colon and the curly braces. So this little code snippet would be really important anytime you want to generate something that looks like a receipt. Now your lab, that is coffee sales, is going to be different than this, but this is a good start. So let's leave it there and move on to the lab programs.